And this year, you all have access to $300 in Google Cloud credits. To claim them, please go to cloud.google.com/free. You will need a valid credit card to get started, and you'll need to be located in one of the Google Cloud Platform territories that's listed in this link. And we are here to help you, and we're going to give you some high-level information on some of the great tools you get with Google Cloud Platform. Over to you, Brian.
Thanks, Tej. So for the next few minutes, we're going to give an overview of Google Cloud Platform and Firebase. Both these platforms are available to you to use those credits that Tej spoke about earlier. Google Cloud Platform is where you'll build the infrastructure to host and run your application. Firebase is a framework of pre-built APIs you can use to add things like third-party authentication to your application once it's built. Let's go into an overview of each. Starting with Google Cloud Platform, these are the compute options you have. On the far left, you have Compute Engine, which are our managed virtual machines. You then have our Kubernetes engine, which is our managed Kubernetes offering. As far as serverless, Cloud Run is offered, where you can bring your own containers and run them in Google Cloud, where Google Cloud will plug in the necessary networking and a horizontal scaling of your application. You can also do things like versioning and canary rollouts. App Engine is another serverless offering like Cloud Run. However, instead of bringing containers, you just bring your code and Google handles the rest. Cloud Functions can be used for asynchronous functions triggered via a webhook or integration to another Google service, such as file storage. So if you uploaded a file and you wanted to kick off some sort of mechanism in your application, Cloud Functions is a good choice for that. When we talk about storing data for your application, we have a number of options in Google Cloud. I've highlighted some of the ones that will be likely most relevant for your applications. On the far left, we have object storage. Cloud storage can be used via REST API to upload data. It's ideal for files such as images, media, or backups. For non-relational databases, we offer Cloud File Store. Cloud File Store, it can be used for keeping application state, things like user profiles, game states, perfect database for that. We're talking about analytical databases. We can use our data warehousing solution, BigQuery. BigQuery is capable of querying petabytes of data, very fast speeds. Moving into some of the services that Google Cloud offers, we'll start with AutoML. AutoML can be used to build and deploy high-quality custom machine learning models with minimal effort and machine learning expertise. It's available for sight, language, and structured data. AutoML will take a fraction of the data that's used for training custom machine learning models and allow Google to find the correct model to use to produce the highest level of accuracy based on the data that you provided. Google will then serve this model for you via a REST API that you can embed in your application. We'll take a look at this a little bit later. If you wanted to develop your own machine learning models, you can use our deep learning VMs and configure the appropriate type of GPUs and GPU type, as well as the ML framework, and even access to a notebook, all in a virtual machine, a few clicks away to spin up. You don't have to install any of this manually. Moving into Firebase, once you have your application infrastructure set up, you can utilize Firebase to configure to use a bunch of modules that are pre-built to do things like third-party authentication or crash data analytics. Firebase is a platform of tools and cloud services that help solve three core problems of your application lifecycle. Develop applications faster with fully managed backend services, run apps with confidence through testing and monitoring, and engage users effectively with better insights and rollout control. Let's take a look at how to build an application with Firebase that's designed to take a PDF and use optical character recognition to pull the data off the PDF and store it into a database. First, the user can use the Firebase authentication framework to authenticate to our app. Then they can use cloud storage to upload a file and store it in Google Cloud that is integrated into a Cloud function that gets triggered once the file upload has completed. The Cloud function can then send the file to our ML kit, which can perform the necessary optical character recognition, and then store the data that is pulled off that PDF into Cloud Firestore, a real-time database. We can then send a notification back to the user or integrate with a third-party gateway via another Cloud function that fires once the data has been stored in FileStore. All these are pre-built modular frameworks in Firebase. You do not have to build any of this yourself. You just configure the Firebase modules to your application-specific needs. Let's walk into a demo of both these platforms. First, we're looking at Google Cloud Platform. You notice I'm in the Beakoff Sandbox project. Your team will have a project. You'll need to give access to the project to your other team members through our IAM permissions. You can access those via the navigation menu on the left-hand side. You scroll down to IAM and admin. That's where you'd go to add their identities to your project and give them access to build alongside with you. This left side menu is where you'll find some of the services we spoke about previously. All our compute resources here, storage, networking, operations, this is where your analytics or logging data would go, and other tools such as Cloud Build where you can use to automate CI/CD workflows. Scrolling down further, is our big data tool sets, BigQuery, one of the analytical databases we spoke about earlier. And then finally, our artificial intelligence platform, L4. A few different versions of this. We have vision, translation, and tables. Let's take a look at AutoML tables. I've uploaded a CSV file into my AutoML tables. If I take a look at this, I can see that Google has parsed each column from the CSV file, and I've configured AutoML to predict the age. When I upload a CSV to AutoML, Google will split the CSV into training data and testing data. I can select the target column that I want Google to predict. After I was to click Train Model, I can test and use the model via a REST API. I can do that right in the console here, or I can plug the REST API into my application. Another feature I want to make you aware of is our Cloud Shell, accessible via this button in the top right of your console. Cloud Shell is a virtual machine that is free, that has about 5 gigabytes of storage, that is tied to your user identity. Only you will have access to this machine. It comes pre-built with popular frameworks like Node.js or Python. So if you're having trouble installing necessary components on your laptops, you can use the Cloud Shell to do development work. And there's also a visual editor here if you click Open Editor. Some other APIs I want to make you aware of is our Vision API. Google Vision API allows you to take images, and I'll start with this image of New York, and it can tell you a whole host of things about that image. For instance, the Vision API has detected certain landmarks in this image, like the Statue of Liberty. It has detected certain objects, like a sculpture in a building. More importantly, and maybe more relevant to your projects, it was able to identify lots of metadata about this image, which will help for classification and perhaps training in a follow-on machine learning model. You can see that it's identified that it's an urban area, it's daytime, there's towers, there's sky, there's buildings, there's river, and so on. Another API I wanted to make you aware of is our Document Understanding AI. This is what you'd use to parse documents, such as PDFs. If I upload a sample invoice, and we allow the API to parse that invoice, we can see that there's a number of fields returned, all the text in the document. However, there's also the tables in the document. And you can see if I highlight one of these, if I click one of these tables found, you see that the document, the associated table is highlighted in the document. and all the text is formatted nicely for me that I can pull out in the JSON response. Bounding boxes are also included. Next, let's move on to Firebase. This is accessed through a different console, however, it's integrated with your Google Cloud account. Under Develop, we have Authentication. I can use these pre-built sign-in methods to allow authentication and access to my applications. I can also take advantage of our cloud file storage, our real-time databases, hosting of static files, cloud functions, and some machine learning capabilities right in Firebase. Scrolling down, I can view performance metrics of my application. There's client-side libraries that you would load in your application that would allow you to see the application start time compared to previous days. You can also see the differences in latencies on your network versus on the device. Next, we can look at analytics. With the Firebase client framework installed in your application, you can see your user engagement, things like total revenue if you're plugging in a feed for that, how stable your app is. This integrates with the crash analytics. Are users adopting your latest release? If you're utilizing things like canary deployments or versioning, you can see the amount of usage on each. You can see how you're acquiring new users, where they're being referred from, the different geographies of your audience, and also the amount of retention. Are users coming back to your application? I hope this quick demo was helpful of Google Cloud Platform and Firebase.
Thank you, Brian, and thank you to all the NASA Space Apps participants. We look forward to seeing what you guys build, and please reach out if we can be helpful. Have a great hackathon. Bye.